Hey everyone, and welcome back to the channel. When we think about space exploration, what comes to mind? Is it the rusty red plains of Mars, the swirling storms of Jupiter, or maybe those tantalizing exoplanets orbiting distant stars? But there's one world, right here in our own cosmic backyard, that's been largely overlooked. I'm talking about Mercury, the forgotten world of our solar system. And today, we're going to explore why it's finally getting the attention it deserves, thanks to the most powerful space telescope ever built. For decades, Mercury has been a planetary enigma. It's the smallest planet, the closest to the sun, and a world of absolute extremes. Imagine a place where daytime temperatures can soar to a blistering 430 degrees Celsius, hot enough to melt lead, while nighttime plunges to a frigid minus 180 degrees Celsius. That's a temperature swing of over 600 degrees. This brutal environment, coupled with its tiny size and proximity to the sun's blinding glare, has made Mercury incredibly difficult to study. Think about it from our perspective here on Earth. Trying to observe Mercury is like trying to spot a fly buzzing around a massive, brilliant searchlight. The sun's intense light scatters in our atmosphere, making it a real challenge for ground-based telescopes to get a clear view, especially during the day. We can only really catch a glimpse of it during the brief windows of twilight, just after sunset or before sunrise, when it's low on the horizon. Even then, we're looking through the thickest, most turbulent part of our atmosphere, which blurs the image. Of course, we have sent spacecraft there. NASA's Mariner 10 flew by in the 1970s, giving us our first close-up look, but it only managed to map about 45% of the surface. Then, much more recently, the Messenger mission orbited Mercury from 2011 to 2015. It did an incredible job mapping the entire planet in high detail and revolutionizing our understanding of its geology and magnetic field. Messenger gave us the what the surface looks like, what it's made of. But a huge question remained: the why. Why is Mercury so strange? Why is it so dense, with such a massive iron core? Why does it have a magnetic field when a world its size shouldn't? To answer these questions, we needed a new kind of eye in the sky. Enter the James Webb Space Telescope. Now you might be thinking, wait, isn't Webb designed to look at the farthest galaxies at the edge of time? And you'd be right. Its primary mission is to peer back into the cosmic dawn. But Webb is also an incredibly versatile tool, and scientists are using its powerful instruments to study objects much closer to home. Webb has a unique advantage when it comes to Mercury. It's not on Earth. It's orbiting the Sun 1,000,000 miles away at a special point called Lagrange Point 2. This location keeps the Sun, Earth, and Moon all behind its massive sunshield, giving it a crystal-clear, unobstructed view of the cosmos. However, observing Mercury with Webb isn't straightforward. There's a rule. Webb can't point too close to the Sun, or the intense light and heat would fry its sensitive instruments. Mercury, being the innermost planet, spends a lot of time in this no-go zone. But the brilliant mission planners at NASA and ESA figured out that there are very brief windows, short moments in the planet's orbital dance, where Mercury is just far enough from the Sun from Webb's perspective for the telescope to safely take a peek. It's a high-stakes precision operation like threading a cosmic needle, and the results are already mind-blowing. Webb isn't just taking pretty pictures like Hubble. Its power lies in its infrared vision. By looking at the heat radiating from Mercury's surface, Webb can do something no mission has done before: create a thermal map of the entire nightside of the planet in one go. Messenger could only measure bits and pieces as it orbited. Webb, in a single observation, can capture a complete snapshot of how the surface cools after the scorching heat of the day. This is a huge deal. This thermal data is like a geological fingerprint. Different minerals and rock types cool down at different rates. By analyzing these cooling patterns, scientists can infer the composition of the surface crust. They can distinguish between areas of solid rock and regions covered in fine-grained regolith, or planetary dust. It's like using thermal goggles to see the hidden texture and makeup of Mercury's surface. This helps us test theories about how Mercury formed and evolved. For instance, did a giant impact strip away its original outer layers, leaving behind the dense, metal-rich world we see today? The composition of the crust holds clues to this violent past. But Webb's investigation doesn't stop at the surface. It's also hunting for the secrets of Mercury's incredibly thin atmosphere, what scientists call an exosphere. This isn't an atmosphere like Earth's. It's a super tenuous cloud of atoms blasted off the surface by solar wind and micrometeoroid impacts. This exosphere contains elements like sodium, potassium, and calcium. With its unparalleled sensitivity, Webb's spectrographs can analyze the faint glow from these atoms. By studying how the composition of the exosphere changes, scientists can learn more about the surface it came from and how it interacts with the constant bombardment from the sun. It's a dynamic system, and Webb is perfectly suited to watch it in action. One of the most tantalizing mysteries on Mercury is the presence of water ice. Yes, you heard that right. Ice on the hottest planet, in the permanently shadowed craters near Mercury's poles, where the sun never shines. Temperatures are cold enough for ice to remain stable for billions of years. Messenger confirmed the presence of this ice, using its neutron spectrometer. Now, Webb is taking the next step. While it can't peer directly into the shadowed craters, its instruments might be able to detect water vapor that gets kicked up from these deposits by impacts or sublimation. Finding and analyzing this water could tell us where it came from. Was it delivered by comets and asteroids? Or was it produced through chemical reactions on the planet itself? This is a key piece of the puzzle for understanding how water is distributed throughout the solar system, which has big implications for the search for life elsewhere. So what does this all mean? The data coming from Webb is essentially giving us a completely new planet to explore. We're moving beyond static maps and delving into the dynamic processes that shape this world. We're learning about its thermal behavior, its surface composition, and its tenuous atmospheric shell in unprecedented detail. These observations will help us refine our models of planetary formation, not just for Mercury, but for rocky planets everywhere, including the many Earth-sized exoplanets Webb is discovering around other stars. By understanding the extreme case of Mercury, we gain a deeper appreciation for the delicate balance of factors that made our own planet, Earth, a haven for life. Mercury is no longer the forgotten world. It's a key witness to the chaotic and violent history of our solar system's birth. And thanks to the incredible power of the James Webb Space Telescope, we are finally able to listen to the stories it has to tell. The era of Mercury's rediscovery has begun, and it promises to be every bit as exciting as the exploration of Mars or the moons of Jupiter. Thank you so much for joining me on this journey to the solar system's innermost planet. What do you think is the most exciting mystery about Mercury that Webb might solve? Let me know in the comments below. If you enjoyed this deep dive into space science, don't forget to hit that like button and subscribe to the channel for more explorations of our amazing universe. Click the notification bell so you won't miss our next adventure. Thanks for watching, and as always, keep looking up.